morning, students. In this session we are going to discuss about functional groups of organic molecules part 2. The first category is carboxylic acid derivatives. In this, the first one is esters. Always the esters end with suffix -ate and the amides end with suffix amide. Amide is nothing but coupling of amine with carboxylic acid, and ester is nothing but coupling of carboxylic acid with alcohols. And the second category is nitrogen based compounds. Number 1 is amine, and number 2 is nitrile, and number 3 is nitro. Let us name few functional groups related with the ester molecules. This is the generalized representation of ester molecules having a 2 oxygen atom. One is carbonyl and another one is ether linkage. This ether linkage oxygen atom comes from the alcohol, whereas the carbonyl carbon comes from the carboxylic acids. For example, ethyl propanoate. Let us have a discussion regarding how to name the compounds of esters. The alkyl chain attached with the ether linkage oxygen has to name first. For example, this is ethyl, so ethyl, and the remaining carbon is parent, so propanoate. Ester has to end with suffix -ate. Similarly here, 3 carbon is there, so propyl, and the parent is only 1, so methanoate. Similarly here, the oxygen is linked with the methyl unit, so methyl, the parent is butanoate. Again, the ether linkage oxygen is having a 3 carbon system, so propyl, the parent is 2 carbon, so ethanoate. Always bear in mind, the carbonyl group attached alkyl chain came from the carboxylic acid, and the ether linkage oxygen atom comes from the alcoholic units. Similarly here, the oxygen is attached with the 5 carbon system, so pentyl, and the parent is 4 carbon system, so butanoate, pentyl butanoate. Let us have a discussion regarding the functional groups amines. And as we know already, this is nothing but ammonia. If one of the hydrogen is replaced by alkyl unit, that is primary amine. If another hydrogen also replaced by another alkyl, so secondary amine. When all the 3 hydrogens are replaced, then tertiary amines. Here I have highlighted few examples for primary, secondary and tertiary. It's very easy to identify which is primary, secondary, tertiary. Suppose when the nitrogen is having a 2 branching, that is secondary, for example like this. Only 1 branching, that is primary. Almost all the branches substitute the alkyl chain, tertiary. Let us have a look at these amine compounds. Since the nitrogen is having only 1 branching and the number of carbon the branching is 4, so butylamine. Here the nitrogen is having only 1 branching, but it is made up of 4 carbons, and the length is carbon is a probe, so substituent is 2-methyl propane amine. Here the nitrogen is having a 2 branching, so it comes under the category of secondary, so dimethyl amine. Similarly here the nitrogen is having a 2 branching, so this is also secondary category, so the parent is prop unit and this is a substituent, so methyl propyl amine. Now let us have a discussion regarding the amides. Amides are nothing but coupling of carboxylic acid with amines. So this C double bond O comes from the carboxylic acid, or sometimes acid chlorides or acidic anhydride, and this N unit comes from the amines. For example, this functional group is amide, so total carbon is but, so butanamide. Functional group is amide, and the nitrogen is having an alkyl unit of ethyl, so N-ethyl butanamide. So here the nitrogen is bearing a 2-methyl unit, so N, N dimethyl propanamides, and this is aromatic butanamides. So with respect to this carbon, this portion is number 3, so 3-chlorobenzamides. Here also I have given some examples. For example, nitrogen is attached with only 1 methyl unit, so N-methyl, the total number of carbon in the system is 2, so ethanamides. Let us move into the next compound called nitriles and nitro. How to naming in nitro groups? So NO2 is nitro, so the number of carbon is 3, so 1 nitropropane. Since the nitro group is attached to the second carbon atom, so 2 nitropropane. And here the functional group is nitro as well as the alkene. As well, we know that the alkene has to give more preference when compared with the nitro unit. So with respect to this, you have to give the numbering. So the nitro acquires a position of 4, so 4 nitro. Since the system is made up of 5 carbon atoms, so pent, and you are having a basic functional groups of double bonds, so pent 1ene. And similarly here 2 nitro and 4 methyl, that is 4 methyl 2 nitrohexane. Let us have a look on the cyanide, that is nitrile. 1 cyanobutane, or including this cyanide unit if you are naming means pentane nitrile. Similarly here 2 cyanopropane, and this is a cyclic nitrile, so cyclopentane carbonitriles, and this cyclohexane carbonityl, and you are having a substituent of methyl here. And this is the structures of compounds having a multifunctional groups, for example, and this is the structure of aspartame. Students, can you able to find out the types of functional group present here? Okay, fine. And this is nothing but a carboxylic acid, and this one is amine, amide, ester, and in this molecule it's an alkene, amide, and here it's an alkene, ketone, ester, and it's a amine, and of more specific it's a secondary amine, carboxylic acid, aromatic system, alkenes and alcohols. And this is a molecule having a maximum more than 5 functional groups. Let us find one by one. And this is amide, amines, and it's a secondary amine since it's having a 2 branching, and it's an alcohol, primary alcohol, alkenes, alkynes, thiols, since it's made up of sulfur units, so we have to use the name thio, so thiol, ketone, alcohol, secondary alcohol, halides, aldehydes. Thank you.